In this second part of this mini lecture, I'm going to talk about the mathematics of projectile. Since we have two components, x and y, I'm going to write the equation. So these are the equations of, I have the x is x0 plus v0 x t plus half ax t squared. And the y would be y0 plus v0y t plus half ay t squared. Now, we can put x0 and y0 to 0. So I will have now x is just v0x t. Now, since there is no acceleration along the x-axis, this is just 0. Now, a projectile is always defined by initial conditions. That means v0 and theta. I can evaluate what is v0x, which is v0 cosine theta. Along the y-axis, you have v0 sine theta. And so I can simplify this equation. It will be v0 cosine theta, and that is t. I can also be more specific about this equation here, eliminate y0 by putting the coordinate system at 0 in a very clever manner. This is given v0 sine theta, so y would be v0 sine theta along the y-axis. The ay is minus g t squared. And so these are the two equations of the projectile. If you give me t, I can figure out what is x and y. If I know the expression x and y, I can figure out vx and vy, because vx would be just dx dt, and vy would be dy dt. So it's very easy. I can figure out this is just v0 cosine theta, and this is v0 sine theta minus gt. So I can also differentiate one more time and end up with the acceleration. This is a constant, so ax is a 0 and ay is minus g. Now, at this point, I have access to all the parameters of the kinematics of the projectile, the x, y, the vx, vy, ax, ay. Now, let's do an example. Or before we do an example, just an observation. In this kind of problems related to a projectile, we ask you very typical questions. For example, what is the highest point? What is the range? That means how far away from the launching point. And so these are typical questions. Let's do an example.